Are you here?
Yes, ma'am.
Okay. Subhana, can you hear me? Okay. Arsha, can you hear me?
Yes, ma'am.
Okay. Martin. Anyway, now see here in the figure, right? This figure. So your AD is already given, right? So this is already given. Okay. Then DB, this is also given. AE, so this is also given. Only this EC is not given. So you have to find this. So I'm just writing here. So okay, so now you put the values. So AD is 1.5, right, centimeter divided by DB. So DB is 3 centimeter is equal to AE is 1 centimeter and EC, right? So now you cross multiply, or first this centimeter actually cancels out, right? So 1.5 then multiplied by EC will be equal to, now 3 will multiply this side. So 3 into 1 centimeter, right? So this EC is equal to 3 into 1 divided by, now 1.5 will come in the denominator and 1 centimeter, because ultimately your answer is in centimeters. So 1 centimeter will remain here. Okay. Now what we can do is we can remove this decimal from the denominator. So
Ma'am, it goes to 2.
yeah, okay, very good. So 15 and then into 10, right? So now you can just simplify. So 3 into 1, 3 into 5, and then 5 into 1, 5 into 2. So this is equal to 2 centimeter, right? So if anybody is having any problem in the calculation, you can ask me anytime, right? That is why I try to do every little step, but still if somebody don't understand, please feel free to ask me, right? Okay. Now, second part also. So this is the part 2. So here everything is given. You can see AD is not given, right? So what is given here in this question? It is given that the line DE is parallel to BC. It's already given, right? Now you have to find, this time you have to find AE, right? Sorry, AD. Okay, so solution. Again, we take the full triangle ABC. So in triangle ABC, right? So we say that DE is parallel to BC. Therefore, from BPT, we can say that AD upon DB is equal to AE upon EC, right? From BPT. So you can write in bracket also from basic proportionality theorem. Okay. Now put all the values here. AD, I don't know, right? DB is 7.2 centimeter is equal to AE is 1.8 centimeter. EC is 5.4 centimeter. So this centimeter cancels out. Now you take this 7.2 here, cross multiply. So AD is equal to 7.2 centimeter into 1.8 divided by 5.4, right? So you can remove all the decimals. So if I remove this decimal, so it becomes 72 divided by 10, right? Into now 1.8. So you remove 1. So you 18 divided by 10 into, now in the denominator, if I remove this decimal, it is 54 and then 10 will come here and 1 centimeter, right? Okay, so at least 110 goes out. Okay. Now, so don't cut 10. Try to use some other number to simplify. So I can, let us use 3. So 3 into 6. 3 into 1 is 3, then 24. So 3 into 8 is 24. 6 into 1, 6 into 3, right? Now 3 into 1, 3 into 2 is 6, and then 12. So 3 into 4 is 12. So now you have 24 divided by 10 centimeter, right? So this becomes 2.4 centimeter. So you have 1 0. So you start counting from right hand side. After one digit, you will put a decimal. Is this clear, everyone? Martin, I can't hear you today. See, everybody is on mute, right?
Yes, ma'am.
Okay. Subhana, can I hear you?
Yes, ma'am.
Okay. Now question number 2. So Subhana, you can ask me if you don't understand anything, right? Right, here is your question number 2. Now what does it say? So E and F are points on the side. Oh, I think I have used the wrong figure. There's no E and F here, right? So we have to draw the figure, I think. E and F are points on the side PQ and PR respectively of a triangle PQR. So let us draw a triangle PQR first of all, right? So figure is not given. So this is the triangle PQR, okay? Now E and F are points on the side PQ. So somewhere you have point E here and F is any point. So I don't know whether it is exactly opposite. It can be anywhere. It can be here, right? I don't know, right? Are points respectively. For each of the following cases, state whether EF is parallel to QR. So this is the line EF if I join it. So in the first case, now what is given here, as you can see, PE is 3.9 centimeter, EQ is 3 centimeter, PF is 3.6 centimeter, and FR is 2.4 centimeter. So in this question, it is not given that EF is parallel to QR, but all the four parts of the lines are given. We have to show whether EF is parallel or not parallel, right? How we will show it? So we will use the converse of basic proportionality theorem, right? So let us revise what is the converse. Like for example, if you have a triangle and let me call it ABC, right? And let's say this is again PQ, right? So if it is already given that AP upon PB is equal to AQ upon QC, right? If this thing is already given, so if this ratio, like this ratio is equal to this ratio, so the meaning is that the line PQ is parallel to BC. Understood, everyone?
Yes, ma'am.
Okay. So this is called the converse of BPT. This converse of BPT. So let us find out the ratio. So left side, so I found PE upon EQ, and then we will find PF upon FR. If both these ratio are equal, then the lines are parallel. So let us find. So 3.9 centimeter divided by EQ is 3 centimeter. Now centimeter gone. Now you remove the decimal. So 39 divided by 3 into 10. 110 will come here. So you can just divide by 3. So 3 into 1 and 3 into 1 and 3, right? So it is 13 by 10, which is 1.3. Clear? Okay.
Yes, ma'am.
All right. Now you put the values here. So PF is 3.6 centimeter. FR is 2.4 centimeter. Again, centimeter gone. When you take ratio of something, it does not have any unit, right? So all the units cancels out from the numerator and denominator. So it's just a number. Now, if you remove this decimal, so 110 will come from the numerator. So it will be 36 by 10 and into, so 24 into 10, right? So both 10 basically cancels out. Now you can use the table of 3. So 3 into 1, 3 into 2, 3 into 8. And now again you can use 4. So 4 into 3, 4 into 2. So it is 3 by 2. So if you divide this, you will get 1.5. So is the ratio same?
No, ma'am.
No. So we say that PE upon EQ is not equal to PF upon FR, right? So this implies that EF is not parallel to QR, right? And in bracket you will write by converse of PPT.
Okay, scroll up.
Yeah, sure. So this figure is actually not of this question, it is of next question, I think. Done, all of you?
Yes, ma'am.
Yeah, I'm
Yes,
doing,
ma'am.
ma'am. I'm doing.
Okay, please do. Try to do the calculations on your own, everyone. Don't copy from the screen, right? Okay, let's do the second part. So again, I'm drawing a triangle here. PQR. And then some points EF are here. Now, what is given? So PE is 4 centimeter, QE 4.5, PF is 8 centimeter, and this is 9 centimeter. So again, we can check, right? So let us find the ratio PE upon EQ. So this is 4 centimeter divided by 4.5 centimeter. Centimeter gone, right? Now you remove the decimal from the denominator. So it is 4 and it becomes 45 into 10, right? Now you can simplify. So use the table of 5. So 5 into 2, 5 into 9. And yeah, that's it. So that becomes 8 upon 9, right? So let's leave this in fraction and let's see the other side. So other side is PF upon FR. So this is 8 centimeter divided by 9 centimeter. So centimeter gone. So this is 8 by 9. So both are same, right? 8 by 9, 8 by 9.
Yeah,
So,
so they're parallel. They're parallel.
so they are parallel. So we write that PE upon EQ is equal to PF upon FR, and therefore the line EF is parallel to QR. Why parallel? From converse of BPT. So you mention the theorem always, right? If you will not mention that, you will lose marks. I mean, from the theorem you are saying that the line is parallel, isn't it? So this is important. Please always write in bracket which theorem you are using here. Now third part, all of you will do yourself. And if you are not able to do, then please ask me. Same way.
I have done, ma'am.
Who? Arshia?
No, Subhana.
Subhana. Okay, good. So done, all of you? Any problem, anybody?
Yeah, ma'am. Do it.
No, ma'am.
Okay, then till then I copy question number 3. Okay, then you can complete the calculation. Now see question number 3, all of you. Right? So in figure, if LM is parallel to CB, that means this LM, right, it is parallel to CB. Understood? And similarly, this
Yeah.
LN, this line is parallel to CD. Fine. So you have to prove that AM upon AB. AM upon, see, it's not MB, right? It's the full length AB. Please see clearly, right? And similarly, AN upon the full length AD. So please read the question carefully. Understood? So, okay, let's start. So obviously, see, this question is from the exercise 6.2. So ultimately you have to use BPT, that you know, right? So BPT, what does it say? Let us take one triangle at a time. So first I am taking this triangle, like this much, right? So I can do it like this. Just take in triangle. Oh, I just forgot to write. First of all, always write whatever is given. So it is given that LM is parallel to CB, right? And LN is parallel to CD. And then what you have to prove? You have to prove AM upon AB is equal to AN upon AD. So you take triangle ABC, right? And here I'm taking triangle ADC, right?
Yeah.
Okay. So one by one, I'll apply BPT. If I apply BPT in triangle ABC, so that means AM upon MB, right, is equal to AN, sorry, not N, AL upon LC. Is this clear?
Yeah, ma'am.
Yes. So this part upon this part is equal to this part upon this part. Now you come to the other triangle. So in other triangle, yeah, from BPT. This you write that from BPT. Okay. Now in triangle ADC, again I can write AN upon ND is equal to AL upon LC, right? Again from BPT. So you can see the right hand side is same. If this is your equation number 1 and this is your equation number 2. So this is also AL upon LC. This is also AL upon LC. So you can say from equation 1 and 2. So if RHS is same, that means LHS is same. So AM upon MB is equal to AN upon ND, right? Okay. Now you see clearly what you have to prove. So this AM, right? This you can see here, it's already here, right? Then you have to show AN. So AN also you can see it's already here, right? Now this MB, this you don't want, right? So somehow you have to change this MB into the full length AB, right? Is this clear?
Yes, ma'am.
Yeah.
Yeah.
Yes, ma'am.
Yeah. So that means you have to add something to MB. Now it's difficult to add something in the denominator, right? So first of all, we will take this into the numerator. So we will just reverse it. So we can write it MB upon AM is equal to ND upon AN. Any problem? No? Right. Now what I will do is I will add 1 on both sides. So you can see what will happen now. Okay, stop. See my screen. I don't know where it is going. Okay. Now you put add 1 both sides. So MB upon AM plus 1 is equal to ND upon AN plus 1. Clear? Right.
Yeah.
Now you take LCM. So LCM will be AM. So AM is already here, so it is only MB plus. So this will be, see you have 1 here, right? So AM into 1, AM will come here. Similarly, this side, LCM is AN. So ND plus AN, right? So now you can see in the figure, MB plus AM becomes your full length AB, right? And similarly, ND plus AN becomes your full length AD upon AN. Now, according to the question, you want your AB in the denominator. So again, you can just flip it, right? So you can
Yeah.
write it like AM upon AB is equal to AN upon AD. So now this matches with it, right? So this is like proved.
Can you scroll up?
Sure. Okay, done.
Yeah, scroll down.
Yeah.
Yeah, I'm done.
Okay. Right. So let's do the next question. Now in figure 6.19, so DE is parallel to AC. So write down, it is given that DE is parallel to AC, right? Now where is DE? This is this line, right? So this line is parallel to this line. Is it clear, all of you? Can you
Yes, ma'am.
spot it?
Yeah, ma'am.
Yeah, so DE is parallel to AC. Okay. And it is given that DF is parallel to AB, right? So DF means this side DF is parallel to not AB, sorry, AE. So this DF is parallel to AE, right?
AC, right? Ma'am.
AE, right? In the question you can see. So this line is parallel to this, right? Like this.
Yeah.
Okay, right. So let us do it one by one. Let's take one triangle at a time. And what you have to prove, that also you write. To prove that BF upon FE is equal to BE upon EC. Okay. So you can see BF is this, right? And FE is this. That means you have to take triangle ABE, right? This triangle ABE, right?
Yes, ma'am.
So if I take like in triangle ABE, now which line is parallel? So I have DF parallel to AE, right? So what does it mean? So from BPT, what can I say? So therefore, like this side upon this side. So BD upon AD is equal to now BF upon FE, correct?
Yeah,
From
ma'am.
from BPT. So you can mark it equation number 1. Okay. So like we have used this information, I mean this one we have used, right? Now come to this information which is given. So DE parallel to AC, that means we have to take triangle ABC, right? So in triangle ABC, see this DE is parallel to AC. So that means triangle ABC you have to take. Understood? Okay. So in triangle ABC, I have DE parallel to AC. So therefore I can write, again I can write, the, what can I write? Yeah, so BD upon DA or AD, right? AD is equal to, this time it will be BE upon EC, right? Because line DE is parallel. So this much part upon this much part. Understood?
Yeah.
Okay.
Yeah, ma'am.
Now you can see both equation 1 and 2, this LHS is same, right? So therefore we can say from equation 1 and 2, RHS is also same. That means BF upon FE is equal to BE upon EC. That's it. This is what you have to prove. Let us come to question number 5. So question number 5 is like important question from examination point of view. And also question number 2, third part, like which I gave you, that might also come. Okay, let's do question number 5. Let me just insert it. So I hope everyone has done. Let us start. Now write whatever is given and then whatever you have to prove. So in figure 6.20, DE is parallel to OQ. So please see in the figure which is DE is parallel to OQ. Okay. And DF is parallel to OR. Now to show that EF is parallel to QR, right? So let us do the proof. See, sometimes you might think like what we have to do, how we have to start. So basically the hint is here, right, in the given. So pay attention to what is given to you. Now you see D is parallel to OQ. So one by one we will take the information. So where is DE? So DE is my this line, right? Now this is parallel to this line, right? So two lines are parallel in a triangle. So if I take this triangle, right? This much, and I can apply BPT, isn't it?
Yeah, ma'am. If we prove the both of the are equal,
Hmm.
yeah.
Yeah. So one by one, let us take. So in triangle POQ, right? PQO or POQ. Okay. So you have your line DE is parallel to OQ. So therefore, what can you write? So you can write that PE upon EQ is equal to PD upon DO. Is this clear?
Yeah, ma'am.
From BPT, obviously. So mark it 1. Okay. Now you take the right hand side triangle. So in triangle POQ, now this time take POR. So here it is given that DF is parallel to OR, right? So this line is parallel to this line. So again, we can use BPT. So therefore, we can say that PF upon FR is equal to PD upon DO again, right? Equation number 2. So if you pay attention again, so PD upon DO and PD upon DO, RHS is again same. So from 1 and 2, yeah, from BPT, please mention. Okay, so from 1 and 2, LHS is same. So you have your PE upon EQ is equal to PF upon FR, right? Okay. So we have got this ratio. Now you have to show that line EF is actually parallel to QR. Now line EF is this, right? And QR is this, as you can see, right? So again, let's go back to the figure. So if I show that this ratio upon this ratio is equal to this, this part upon this part, both the ratio are same. What does it mean? It means that line EF will be parallel to QR, right? Converse of basic proportionality theorem. Okay.
Yeah, ma'am.
Yes. So I have already got this ratio. So PE upon EQ is actually equal to PF upon FR, that we have already proved. So therefore, we can say that line EF is parallel to QR. Why we can say? Converse of PPT. So both the theorems we are using. Like one time BPT we are using, then one time converse of BPT also we are using. Okay, after finishing this chapter triangles, I will take a test, okay? I will announce in the next class. So please prepare for the test, all of you.
Okay.
And Abdullah, please attempt the test next time, right? Yes, Abdullah, unmute yourself. Okay, Abdullah is gone, I think, right? Okay, he's not here. I hope you are done. Next question now. Right, this is the figure. Let us see what is given here. So A, B, C, as you can see, A, B, C, right, are points on OP, OQ, and OR respectively, such that, so it is given that AB is parallel to PQ. Second thing which is given, AC is parallel to PR, right? To show, you have to show that BC is parallel to QR. Okay. So here is a hint. Ultimately, in the end, you are going to use converse of PPT, right? Okay. So we will start from the given condition. So we will take hint from here. So first of all, it is given that AB is parallel to PQ. So where is AB? Now you can see AB is here, right? And PQ is here. So which triangle I have to take?
Ma'am, AOPQ.
No, not AOPQ. That's only
No,
three.
ma'am, I told OPQ.
Yeah, OPQ. Very good. So in triangle OPQ, you have AB parallel to PQ, right? So from BPT, we can say, therefore, from BPT, you can write that OA upon AP, right, is equal to OB upon BQ, right? Is this understood, everyone? Mana,
Yeah, ma'am.
Subhana, understood?
Um,
Okay. Now come to second given condition. So you have AC parallel to PR. Now where is AC? So AC is this side, right? PR is this side. So which triangle you have to take? POR this time, right? So AC is parallel to PR. Therefore, from BPT, you can say that again, you can say that OA upon AP is equal to OC upon CR. Any problem?
Ma'am.
No,
Yeah.
ma'am.
So if you again compare them, if you call them 1 and 2, so you see that this is also OA by AP, this is also OA by AP. So that means RHS is also same. So from 1 and 2, right? So we can say that OB upon BQ is equal to OC upon CR. So this much we have got so far. Let us come back again to the figure. Now look carefully, sorry. OB, where is OB? OB is this, right? Upon BQ, that means BQ is this. Understood? Is equal
Yeah,
to OC, that means this, upon CR, that means this. So the like this part upon this part is equal to this part upon this part. Okay, now tell me which line is parallel to which line?
BC parallel to QR.
Very good. So okay, so now sorry, you take a triangle first of all. So in triangle OQR, right? So this time I'm taking this triangle OQR.
Yeah,
Okay. So in triangle OQR, so we have just shown this result that OB upon BQ is equal to OC by CR, right? Uh, Proved above.
yes, ma'am.
You can say proved above, right? So therefore, BC will be parallel to QR, converse of BPT. Okay, next question now. Now using theorem 6.1, that means BPT, right? Okay, prove that a line drawn through the midpoint of one side of a triangle. So if I draw a triangle, let me call it ABC. So if I take the midpoint of AB, so let's say D is the midpoint of AB, right? So if a line is drawn through the midpoint of one side of a triangle parallel to the another side. So from D, I'm drawing a line parallel to BC, right? Like this. Uh, bisects the other side. So let's say D, I'm just extending it and it meets EC at point E, right?
Yeah,
So
ma'am.
I am not saying that E is the midpoint. I have to prove that E is the midpoint of AC. I only know that D is the midpoint of AB and the line DE is actually parallel to BC. That's all I know. So you have to prove that E is also the midpoint of E is the midpoint of AC. This is actually midpoint theorem which we proved in class 9th. So we proved it in a different manner. Now we will prove it using theorem 6.1, that is BPT, right? Okay. So write down what is given here. So it is given that D is the midpoint of AB. Okay. And it is also given that DE is parallel to BC, right? And you have to prove that E is the midpoint of AC. Let us start. So we start from BPT again, like it is mentioned in the question that you have to use BPT. So I take triangle ABC. So in this triangle, I can see that DE is parallel to BC. This is already given, right? So therefore, I can say that AD upon DB is equal to AE upon EC, right? So here I have used BPT. Understood?
Yeah.
Okay. Now, because again there is one given condition that D is the midpoint of AB. What is the meaning of it? The meaning is AD is actually equal to DB, isn't it? Yes?
Yes, ma'am.
Yeah.
Yes,
So you can say, okay, you can call it 1. So since D is the midpoint of AB, right? It is given. So we can say it implies that AD is actually equal to DB, right? Now use this in equation 1. So equation 1 becomes, so in place of this DB, I can simply write AD, right? So it becomes AD upon AD is equal to AE upon EC, right? So 1 is equal to AE upon EC, right? So that means if you cross multiply, so EC is equal to AE, right? So that means this part is equal to
yeah.
this part, and this means that E is the midpoint of AC, right? So this implies that E is the midpoint of AC. See, after completing triangles, first of all, I'll take a test of some chapters. So I'll think about it. I'll tell you in the next class. And then again, we will be doing trigonometry, right? So I started revision, but after one exercise, we stopped. So we will continue with trigonometry.
Okay, ma'am.
Okay, just tell me one thing. Martin, do you have R.D. Sharma book?
Yeah, ma'am.
Okay. And Mana, do you also have R.D. Sharma?
No, ma'am.
No, you don't have. Okay. Mm, so if I was just thinking that in case you were having, so we can directly do R.D. Sharma questions, right?
Yeah,
Because
okay.
we have a lot of time for the exam and only 3 chapters are remaining in the syllabus.
Yes, yes, ma'am.
Mm. So Mana, can you just find on the internet if you can download a PDF or something of R.D. Sharma? Just to give it a try, right? So that will make things easy, like when you have the book in front of you, so the questions at least will be visible to you. So we can directly do some exercises. It will give you a good practice. They have a lot of questions for practice.
Okay, ma'am.
Okay, so please try if you can get that book. Okay. So I'm just stopping here. The rest of the part of triangles, I hope I'll complete in the next class. Okay.
Okay, ma'am.
Okay then. Bye.
Thank you, ma'am.
Thank you, ma'am.
Okay. Thank you. Bye. Okay, Subhana, bye. Yeah, Hamna, can you hear me now?
Yes, ma'am.
Okay. So today I'm planning to do a revision of linear equations in two variables, right? So basically, I have put in some questions here. So you will solve them one by one, and then we can discuss if you're not able to solve. So I have several questions here. So you please start solving and just let me know if you are stuck somewhere.
Okay.
Okay. And once you finish one question, please send me a picture so that I can do the assessment right here.
Ma'am, I have a doubt in yesterday's question, in last class questions.
Which questions were
Ma'am, of coordinate geometry.
coordinate geometry? Can you tell me the question?
Yeah, ma'am, just done that. Ma'am, I'll forward you the screenshot.
Okay. Yes, Harsha. So what is the doubt here?
Ma'am, can you explain the 6th and the 10th question?
6th and the 10th. Okay, I think I gave this in the practice. All right.